Hi there, since my last video Earl's completed his odds and ends engine and he's uploaded a couple of videos to his channel which I'll include links to in my video description, but this is a brief extract of one of them. And also Andy Matthews has sent me a brief video of the Jerry Howell hit and miss engine that he's completed recently, so I'll show you a brief clip of that as well. So in this video I'm going to start work on the Hoglet, which is a V-twin. And if I can make this, fingers crossed, I should be able to make the Jerry Howell V-twin, which is a bit more complex. And you can download the plans for the Hoglet from the modelenginebuilder.com website. The plans are in issues 10 and 11, and each issue costs around about £3.50, that's UK pounds, which is a bit of a bargain really, I would have thought. And in this video what I'm going to do is I'm going to start work on the crankcase. Okay, so the crankcase sides are made out of two pieces of aluminium 1/4 of an inch thick, and they consist of a front piece and a rear piece, and the outside dimensions of both the front and the rear are identical. So what I'm going to be doing is I'm going to super glue these together before I machine the outside edges. So these portions here need to be machined out. There'll be a radius on these corners, and these top edges here are at 21 degrees. So in order to get those accurately, what I did was I made a little piece of aluminium to be 21 degrees of an angle there, and to work that out the bottom edge is 2 inches and this side is 0.384, so that actually gives the tangent here of 21 degrees. So having made that, that's allowed me to scribe lines more accurately, and also when I mill these pieces in the vise I can use this piece to actually hold it sort of horizontal. Now the front piece consists of a main bearing for the crankshaft and a camshaft bearing. Now the drawing suggests using some oilite bronze material, but I'm not too happy with that. What I'm going to do is I'm going to try and convert to ball bearings. So these are bigger than the drawings. So I'm going to have a ball bearing like that and a ball bearing like that. And the front has also got 3 holes here which are drilled and tapped to hold the cam housing. Now the rear bit only needs to be drilled out to hold the other main bearing down there. So that's the plan. So I'll Loctite or glue these together, and then I'll go over to the mill and start machining. Well, I've cleaned up all 4 sides so they're nice and perpendicular, and it's probably worth mentioning that I only mark up as a guide. So I'm going to use the DRO for accurate sort of positioning, and I'm going to focus in on that point. I'm going to set the DRO to 0 on the X and Y axis at that point, and then I can calculate all my distances from there. Okay, so I'm spotting that mark now, and I've zeroed the X and Y axis on the DRO. Okay, so I'm going to use the dimensions in the drawing to mark the sort of key points using this centre drill. And now for this area that's going to be removed, I'm going to use this slot drill to drill right through and put a radius on the corner. Nearly there, the camera's in the way, so I'll drill right through and then I'll complete the other 3 off camera. Well, I've just had a bit of a rethink. I was thinking about boring this hole out for the main bearing using my boring head, but I'm not sure I can achieve the accuracy that I'm after. This hole needs to be around about 2/10 of a thou less than the outside diameter of the main bearing, because I want a transitional fit. So I think what I'm going to do is I'm going to put it on the lathe in the 4-jaw chuck, because I think I've got more chance of getting that accuracy using a boring bar. So I've centred on the centre drill mark, opened it up with a 6mm drill bit, and this is a slightly bigger drill bit. Taking it nice and easy. I think I've got that just about right. It's just a tight fit, is that? I think it'll press in very easily on the press. So I'm happy with that. So I'll take it off the lathe and go back to the mill. Okay, so having cut the hole for the main bearing, I've decided that probably the best approach now is to mill out some of these sections here while these 2 pieces are joined together. So to mill out that angle there, I'm going to use this like that. So that'll go at the bottom of the vise, and that should give me the horizontal edge there. Okay, so it seems to be going to plan at the moment. What I need to do now is to drill and tap some holes here, and the drawing calls for some UNC threads, but I think I'm going to go with M4 because that gives me some better options, I think, going forward. And I need to drill some clearance holes here. Once I've done that, I'll heat the two pieces up and I'll split them, but I'll do all that off camera, and then I'll get back to you. And just out of interest, this is how I tapped the holes at an angle. Now the gears that are going to be used in this engine are 32 DP, and one of them is 40 teeth to a gear, and the other gear's got 20 teeth. Now the pitch circle diameter of a gear is equal to the teeth divided by the DP. So the pitch circle diameter of a 20-tooth gear is 20 divided by 32, which gives 0.625. The pitch circle diameter of a 40-tooth gear is 40 divided by 32, which gives 1.25 of an inch. So the distance between centres is equal to 1.25 plus 0.625, all divided by 2, which gives 0.9375 of an inch. Now the drawing shows the distance between the centres as 0.938, which is perfect. Half a thou over, which is great. However, I've made life a bit more complicated for myself, because when I marked these positions up, I did it on the milling machine, but then I went over to the lathe and machined this hole here. Now I only need to be out by a few thou, and the gears won't mesh properly. So what I need to do is I need to re-establish this point on the milling machine, the centre point. So I'm going to do that using a coaxial indicator. Once I've found that centre point, then I'm going to re-establish this centre point here to be 0.938 of an inch from that point. And I'm going to re-establish these points as well. So these will be drilled and tapped to M4. And this needs to be opened up to 3/4 of an inch for this ball bearing here. Now unfortunately I have not got a 3/4 of an inch reamer, and you know it's going to make life a little bit more complicated if I try and do it on the lathe again. So I found this slot drill, 3/4 of an inch slot drill, which I think might work. I think the hole will be sort of slightly smaller than what I'm aiming for. But hopefully I'll be able to sort of press it in. But anyway, that's the plan. Okay, I've re-established the centre and set the X and Y axis on the DRO to 0. Okay, so I've moved the X axis to the right by 0.938 of an inch. So we'll see if we can drill this hole for the other bearing. I think that should press in okay. So what I'll do now is I'll drill and tap these 3 holes to M4, but I'll do that off camera. Well, in the end I decided to put an M5 thread in here, but everything's looking good. Really happy with the way they've pressed in. So what I need to do now is to make the tops. So the 2 tops are identical, so I've just super glued these 2 pieces together and cut them to size. And what I need to do is drill 4 holes here, which are M4 clear, and drill and tap 4 holes M4 thread, and then once I've done that I just need to open this up, put a hole through there, and I just need to put a little angle on this side here of, can you believe it, 21 degrees. Okay, so I've just used an edge finder to find this edge and the centre, and then I've moved the x-axis across this way by 0.803 of an inch, and that's put me on the centre of the hole that I need to open up. So what I'm going to do is I'm going to drill with a centre drill and then open it up with various sized drills, and then use a boring head. And this should be the final cut. Well, I think I'm about 1/8 thou over, so hopefully it's not that critical. So what I'll do off camera, I'll drill and tap the various holes. So to get the correct angle, I'll put this back on here. Like that. So that is at 21 degrees. So I need to lightly skim this material off here until I get a point on this side here. So that looks pretty good, so I need to repeat the same process on the other piece. Well, that was quite enjoyable, and making this little angle, the 21 degree angle, came in really useful. And it even enabled me to get this top join spot on. And I'm glad I've gone with the ball bearings. That's a dummy shaft, which turns very nice and smoothly. It's a shame I've not got the gears, because then I could check the distance between centres. But I think that'll be my next video, making the gears, followed by the cam housing. And it'd be nice to know that everything works together nicely. Yeah, happy with the results so far, and I hope some of you have a go at making a Hoglet along with me, because it looks like an interesting build. But anyway, I hope you found the video of interest, and I hope to see you later.